So in this section of the build, we're going to put together the Quadrature Sampling Encoder phase shift network. And the function of this is to take the INQ signal, audio signal, from the computer, and it runs it through this phase shift network and produces signals at 0, 180, 90 degrees, and 270 degrees. Again, all at audio frequency. These 0, 180, 90, and 270 are then fed into the FST 3253 for further encoding. So to test this, what we're going to do is simulate the INQ signals with a 0 and 90 degree audio signal coming in here, and we should see the 0, 180, 90, and 270 audio signals coming out here. So there's a bit of work in putting this together. There's actually two surface mount components for the op amps. They're both dual op amps. And then there's a pile of resistors and capacitors that make up the phase shift network. So we'll get on with putting that together. Just quickly, where that all goes on the board itself is so here's the input jack here, and then the phase shift network consists of this section of the board here, and of course the SMD components are on the reverse of the board as usual. So we'll get on with putting that together, and then we'll come back and test it. Okay, so we're ready to move on to testing the phase shift network as a part of the Quadrature Sampling Encoder Before I do that, just a few quick build notes. The previous section there's no great challenges there. You just have to remember to observe the polarity of the electrolytics. You have to make sure you line up, there's a line on the SMD ICs, the op amps, and that aligns with the minus sign on the PCB. And then the final one is the orientation of these two jumpers here. Now basically the orientation of these jumpers will very much depend on your SDR software itself. So with HD SDR, it doesn't matter. You can adjust which channel is I and which channel is Q in the software itself. So I've just got them straight through like I had on the receive circuitry. So let's move on to testing, and I'll just quickly go through the test setup here. If I just pan up to the schematic. So what I've actually got here is I'm feeding into, so this is a stereo jack here, and I'm feeding in a 1 kilohertz signal, two 1 kilohertz signals 90 degrees out of phase with each other. And then I'm probing to confirm that I'm getting the correct phase shift. I'm probing these points here, which is at resistors R26, R25, R28, and R27. And I should see the 0, 180, 90, and 270 outputs there. So let's move on to the first phase of the test here. So what I'm actually probing, let me get everything in the video here, so bear with me. So what I'm probing now is I've got a probe on the channel 1 input from the signal generator, and I'm probing resistor R25. And if you have a look on the oscilloscope, what you'll see is those two signals are exactly in phase. So let me just show that by, let me get my hand out the way, let me show you that by adjusting that. So you can see that those two signals are exactly in phase. So that's at R25. So the pair of R25 is the resistor R26. So what we should see by probing R26 is that those signals will be 180 degrees out of phase. And you can see that they indeed are. And of course these signals are all at the audio frequency that I'm feeding in 1 kilohertz. So let's move over to the other channel of the signal generator. So bear with me here. There we go. And I'll first probe pin R27, which is right here. And you can see I've got the same situation here. So this signal at R27 is exactly in phase with the with channel 2 from the signal generator. In a similar fashion, when I probe pin 28, you'll see that those two signals are now 180 degrees out of phase. So let's just finally go through the progression of the signals from 0 through 90, 180, 270. So I'll move my pin back onto channel 1 here. Bear with me, it's a little bit tricky. That's looking good. And now what I'll do is I'll start with R25, and you'll see that they're exactly in phase. Now the 90 degrees out of phase one is R28. So here's R25, completely in phase, and then R28, you can see that it's now 90 degrees out of phase. So moving on, we should see the yellow signal here move to 180 degrees out of phase by probing at R26, and you can see that. And then finally, the yellow signal there, if I probe at R27, will be 270 degrees. So this proves that this part, the phase shift network part of the QSE, is all set up and ready to go. Now, one of the things to bear in mind, I'm just injecting a 400 millivolt signal here. As you can see, there is no gain in this section at all. you can see on the oscilloscope, well, you probably can't see on the oscilloscope, but I'm injecting a 400 millivolt peak-to-peak signal. I'm getting a 400 millivolt peak-to-peak signal or thereabouts on the oscilloscope. So there's no gain in this stage at all. But this does prove that I'm getting the 0, 90, 180, 270 degrees output that the follow-on stage, the FST3253 Quadrature Sampling encoder itself requires. So that's the next phase of this build, is to basically put in the FST3253. There's a transformer behind that again, and we should be able to probe the output of that and see the up-converted signal from that. But that's the next stage of the build.